Okay, good day everyone. So today my group and I will be presenting you about pulse modulation and multiplexing on how pulse modulation and multiplexing works and its impact and how it is changing the world. This presentation is done by group 11. So yeah, this is the list of content that we will be presenting you today. We will go through with introduction, pulse modulation, multiplexing, recent advancement, impacts and benefits to society, and last of all is the misconceptions. So, for starters, for the introductions, pulse modulation and multiplexing are actually the most fundamental technique in the modern communication system that actually enables efficient transmission of information from one end to another. So, pulse modulation involves in encoding data into pulse signal, while multiplexing allows multiple signal to share a single communications channel. So, yeah, so, with the most recent advancement is of course the 5G technology. Second of all is satellite and IoT connectivity, and last of all is of course the hot topic, which is AI-powered signal processing. So, this is due to the advancement of primarily due to multiplexing, as 5G technology uses the orthogonal frequency division multiplexing to enhance bandwidth efficiency and reduce interface, enabling massive MIMO, which is multiple input, multiple output for improved data rates. And second of all is the satellites and IoT connectivity requires time division multiplexing and frequency division multiplexing, which is the TDM and FDM, to handle multiple data streams efficiently. This supports large-scale device connectivity in very low-power networks. And of course, for the AI power signal processing, it actually AI optimized signal routing, bandwidth allocation, and interference reduction, all of which rely on advanced multiplexing techniques, which enables adaptive spectrum sharing and predictive signal processing for real-time adjustment. So the role of PCM in here is still very crucial for digital voice, video, and audio transmission. It ensures the accurate signal representation in digital form. Yeah. So that is how this both of this multiplexing and pulse modulation is changing the world right now. And the impact and benefits to the society is so much more that I only can choose three to share with, which is faster and more reliable communication. Which because multiplexing allows high-speed data transmission, as I've mentioned just now, it is used in 5G, fiber optic, internet, and of course satellite networks. Second of all is that it improves healthcare and remote services, because multiplexing in medical imaging, such as MRI and CT scans, allows faster diagnostic. And last of all is the enhanced digital connectivity supports smart cities, IoT, and of course cloud computing. So yeah, that's all from me. I shall move to my next group mate. Thank you.
So now let me talk about what is pulse code modulation, which is also known as PCM. PCM is a widely used technique that represents an analog signal in a digital format. It follows three key steps. The first step is sampling, where the analog signal is sampled at a discrete time interval. And the second step is the quantization step, where each sample is assigned a fixed amplitude level, which means rounding it to the nearest available value. And the third step is coding, where the quantized value are converted into a binary format that the computers can process and store. So basically, PCM is a foundation of digital audio used in everything from phone calls to CDs and streaming services. It ensures that our voices, music, and other sounds can be transmitted and stored efficiently in digital systems. So let's go detail into each step. So the first one is sampling. Well, sampling involves converting a continuous analog signal into a discrete time intervals. So to prevent any aliasing, the signal must be sampled at a rate equal to or greater than the implicit rate of the sampling rate more and equals to two times of the modulating rate frequency. An anti-aliasing filter is applied before sampling to remove any high frequency noise. There are three types of sampling. The first sampling is the ideal sampling, which is the theoretical concept, and the second one is natural sampling, which is practically implemented, and the third one, the most commonly used in PCM, is the flat top sampling. This step is crucial for accurate digital signal representation. So now we'll go to the second step, which is the quantization. So in quantization, what is quantization? Quantization is a process of converting sample values into discrete amplitude levels. It helps in representing the analog signal in a digital form. And quantization interval, V, it determines the difference between adjacent levels. More levels increase the precision but also require more storage. There are a few types of quantization. The first is uniform quantization, which has equal step sizes. And the second one is non-uniform quantization, which has smaller steps for low amplitude, improving signal to noise ratio SNR, also known as SNR. Quantization error. The maximum error is half of the quantization step size. Increasing the bit depth reduces the noise and improves accuracy. This step is very crucial in minimizing distortion and improving the signal's quality. So that's for quantization. And for coding, well, coding converts quantized value into binary codes, allowing digital systems to process and transmit information. There are Types of bit encoding. One common method is the sign magnitude coding, where we use a sign bit to represent positive or negative values. Another method is the binary representation of levels. For example, with a 3-bit encoding, we can represent as 000, 001, 010, and so on. So for the bit rate tells us how much data we are transmitting per second. It's calculated as, with the formula, bit rate equals to n times sampling frequency. N is the number of bits per sample, and fs is the sampling frequency. A higher bit rate means a better quality, but also more data to store and transmit. So now let's talk about the advantages and disadvantages of PCM. Well, for advantages of PCM, it has high noise immunity. It's immune to very, very high noises, and it can be stored and also processed very easily. It also enables encryption and error detection. It's suitable for digital transmission and also multiplexing. How about the disadvantages of PCM? It requires a larger bandwidth, and analog signals must be converted before transmission, and synchronization is needed for accurate decoding. So that's all for PCM.
Hi everyone, my name is Lo Baoliang. So I'm going to introduce about what is multiplexing. So multiplexing allow multiple signals to share a single communication channels. It's widely used in telecommunications, broadcasting, and networking to transmit multiple data streams simultaneously. So actually, we got four types of multiplexing. So I will start with the first one, time division multiplexing, TDM. So TDM divides the transmission time into fixed length time slot. Each signal is assigned a specific time slot, and the signal take turns transmitting over the shared channel. Signals are transmitted in rapid successions, one after the others, within their allocated time slot. So it used in digital telephony, commonly used in synchronous communication system. So efficient use of bandwidth. Simple to implement in digital system, require precise synchronizations, inefficient if some time slots are unused. So the second one will be the FDM, frequency divisions multiplexing. So FDM assign each signals a unique frequencies, then within the available spectrum, all signals are transmitted simultaneously but at different frequency. The total bandwidth is divided into smaller frequency bands, and each signal is modulated to its assigned frequency. So it commonly used in radio and television broadcasting, common in analog communication system, no need synchronizations, suitable for analog signals. And it also requires guards bands to prevent interference, limited by the available frequency spectrum. So the third one will be the wavelength divisions multiplexing, WDM. So WDM is a variant of FDM used in optical fiber communications. It combines multiple optical signals of different wavelength colors onto a single fibers. Each signal is assigned a unique wavelength, and all signals are transmitted simultaneously over the same fiber. So it used in high-capacity optical networks, and it enables long-distance communications with minimal signal loss. It extremely high data transmission rate. It also efficient use of optical fibers bandwidth. It requires expensive optical equipment, and it complex to implement and maintain. Okay, so the last one will be the space divisions multiplexing, SDM. So SDM uses physical separations to transmit multiple signals simultaneously. So each signal is transmitted through a separate physical path. Multiple cables or fibers are used to carry different signals, or multiple antennas are used in various communications. It used in multi-core fiber optics for high-capacity data transmissions, common in MINO, which is multiple input, multiple output technology in wireless communications. It increases overall system capacity by adding more physical channels. It reduces interference between signals, require additional physical infrastructures. So I think that's all about the multiplexing. That's all. Thank you.
However, there is still some misconceptions towards the usage of multiplexings and also pulse modulations. So in the following parts, I'm going to address all these misconceptions. So first of all, why we need to address the misconceptions? Because we want to ensure that the public awareness and they are having the correct understandings towards all these pulse modulations and also multiplexings, and prevents the misinformations that could hinder technological advancement. So first one, I want to talk about the health issues. Some people claim that 5G and multiplexings can cause cancers. So in reality, there is actually no scientific evidence that links 5G or multiplexings to cancers. We also have a lot of regulatory bodies like WHO, FCC that already set a safe exposure limits towards the radiations. We can have some resolutions like having public awareness campaigns based on scientific research to make people know that these multiplexings and pulse modulations do not cause cancers. And for the second one, wireless signal causes headache and also insomnia. EMF exposures from pulse modulations leads to headache and sleep disorder is actually not true in realities because there is no study can conclusively prove EMF cause health issues. However, other factors like screen time and blue lights, they actually impact our sleep more significantly than the EMF. So it's better for you to follow self-device usage practice rather than saying that EMF is the main causes. So coming to the safety issues, multiplexing can cause signal failures in critical systems. So multiplexing in aviation, healthcare, and defense increase the risk of signal failures. In realities, our technology is actually become more modern and we use a lot of redundancies, encryptions, and error corrections. So the hacker is actually not that easy to hack into the systems. And next thing is multiplexing compromise data privacies. So Sam, we have a lot of encryptions like AES, end-to-end securities. So although the security risks still exist, but actually it's going low. Okay, right? And the data privacy law like GDPR and PDPA also keep us more safe. So coming to the legal issues, so country can use any frequency band freely, like they can just use any frequency band they want. So actually, all these frequency allocations is regulated by ITU, FCCs, and local telecom authorized. Unauthorized usage can cause interference and legal issues. So a company must have a frequency license before they can use it. All right, so it's not as easy as people thought. So last, I'm going to talk about the cultural issues, which digital education is only for developed countries. So in realities, multiplexing enables remote educations in rural and developing areas via satellites and wireless technologies. So a lot of initiatives like the Starlinks invented recently and also the 5G expansions is really bridging the digital divide. So those in rural countries can also access to all these advanced technologies. So digital education reduce human interactions is also a misconception because while online learning change the interactions, it enhance the accessibilities and also collaborations. Although it is true online, but sometimes we are having the blended learning modes can be a better products of educations. So I think basically that's all from me. Thank you.